Hi, I'm Lyle Stevick, and this is a series of videos on how to make a 3D printed hand drum. The first video will be for the upper part of the body of the drum. The second video will be for the ring that compresses the drum head. The third video will be for the bottom half of the drum body. And then the fourth video will be how to attach the bolt flange as part of the third drawing. My fifth and last video will be on how to decorate a hand drum with two-part epoxy and glitter. I started out my drum project making flower vases. These vaguely resemble an upside-down hand drum. And making something this small allowed me to work through all the technical difficulties of printing with carbon fiber polycarbonate. And so it saved me a lot of time and materials, but it also trained me to draw in this orientation, and this is how I draw all my drums. This is my 3D printing flower vase hand drum project. The three drums on the right are in the decoration video. These got sent off as Christmas presents, and I'm playing a copy of the one in the middle. To make these drums, I'm drawing in FreeCAD 21.2, I'm slicing with Ultimaker Cura 5.9, I'm printing with my Snapmaker A350 version 2, using a 1.8mm nozzle from Slice Engineering, and using carbon fiber polycarbonate filament. I'm recording with OBS 31.0 and editing with OpenShot Video Editor. To start with, there are two crucial items. The first is inspiration. That's the desire to play your instrument every day and actually put your heart into it when you play. That's something you can't buy at the music store. No matter how much money you have, no matter how badly you want it, inspiration is something you have to get from the inside. The good news is you can create it. If you put a lot of creative energy into making your own drum, you'll be drawn to it. It's human nature. Take advantage of it. Forget everything you heard in that movie Amadeus. Musical talent has nothing to do with your genetics or your last name. It has everything to do with how much you've inspired yourself to play on a regular basis with your heart into it. So I encourage you to go all in. Learn FreeCAD. Draw your own drum with its unique shape and sound. Print it yourself, decorate it yourself. The second crucial item is the fit test. That's the first 2 millimeters that make contact with the drum head. This is a Remo M9. It's 7.125 inches across, or a diameter of 175 millimeters. Now in my drawing I use a radius of 87.5 millimeters. For the fit test, this is the fit test for the ring. This took 16 minutes and 18 grams. Now here is the ring itself. This took 5.5 hours and 260 grams. The fit test for the drum body is even starker than that. This is 8 minutes and 8 grams. The drum body is going to take well over a kilogram. So the process is, have the drum head in hand, make the measurements as best you can, and then print the fit test. This will save you a lot of time and materials and grief. Let's draw the drum body top. I'm going to go into FreeCAD and First, I'm going to double check that I am in the part design workbench. Then I want to open a new file, new body and new sketch. And I'm going to draw this sketch in the XZ plane. This will allow me to rotate. Actually, I think the other planes allow you to rotate, but when you get into the drum body bottom, and all the details for the flange, the bolt flange, you want to have the drawings in the XZ plane. So using the fit test measurement of 87.5 millimeters, I'm going to draw a line and set the endpoint as 87.5 millimeters. Now I want this line to be 35 millimeters long. This will let it clear the drum head before I start making my arcs. And I want this line to be at a 96-degree angle. Now you can see that what I'm going to point at here is where the drum head goes. Okay, and the drum head has a measured angle of 102 degrees. So I want to make sure the drum head does not jam against the drum body. Now, if you're using an animal skin drum head, which is much more stretchable, you probably want to make that angle 90 degrees, or closer to 90 degrees. The first thing I'm going to do is draw a construction line, and I'm going to set that construction line as 90 degrees to my first line. Now, any arc that I draw with a center point on this construction line will make a smooth curve with that first line. So I go back out of the construction line mode and I draw an arc with a center point and two end points. So when you have an arc with a center point and two end points, the first left click is always the center point, and then the second two clicks are the end points. Now I specify how far that center point is from the Z-axis, and then I delete this construction line. And now I want to be very careful that I don't move anything while I specify how far the center point is to the X-axis, and then how far the endpoint is to the Z-axis. And once I do that, it should turn green, and that is a fully constrained sketch. So after I draw each arc and each line, I always want to have a fully constrained sketch. That way I don't have to backtrack and figure out what I did. Now on this one, I'm able to, as I'm drawing the line, I'm able to connect to the endpoint and the center point, because the center point of my next arc is actually going to be in between the two. So I'm going to swing that around a little bit tighter than the first arc, and again I specify how far the center point is to the Z-axis, and then I delete the construction line. And I follow that process all the way along the outer wall of the drum body. So I have 4 arcs. I start out with a line, and then I have 4 arcs. And this is going to have a total height of 212 millimeters. So for this particular drum body, you need a machine that can print 212 millimeters, and also a diameter of a little over, since it swings out, a little over 175 millimeters. Also, the filament that I'm using is a very high strength filament, carbon fiber polycarbonate. These drums are really, really strong, long lasting, and they're also very lightweight. If you've ever held, if you look at how I'm holding the drum there, a normal drum would weigh 5 to 10 times as much, and you get fatigued a lot faster on a normal drum. This drum weighs, the one I'm playing there, weighs less than 2 kilograms total, and it's very easy to hold for a long time. Now you'll note that even when I'm swinging out in the other direction, as long as I have those center points and the end point all on the same line, I end up with a smooth curve. So now I have one last arc to make, and this arc, I'm going to have the center point and the end point horizontally constrained so that I have a flat spot that the two body pieces join together on. And I also put a notch in it so that the two pieces center on each other. So here I'm drawing my last construction line and my last arc. Now I know I could have sped this part of the video up, but I want you to be able to see the numbers and see each click because this is the really important part of the video. And you want to take a lot of time on this. This is iteration 7, which I've drawn a gazillion times for this video, but the other 6 iterations were of a different shape. You know, each one was a slightly different shape. And keep in mind that when you change the shape on one of these drums even a little bit, you get a different sound. I have 3 drums that I'm playing in this video that have the same Remo bongo head, and they sound different from each other. So now that I have the outer wall of the drum drawn, I'm going to move across towards the inner wall. And I'll use 3 lines to do that because I want to have a notch, like I said, to center the 2 pieces. And the inner wall and the outer wall are going to be 5.4 millimeters apart. That's going to be 3 line widths when I'm printing with a 1.8 millimeter nozzle. And you'll notice that all 3 of these points are going to be horizontally constrained. So first I constrain those 2 points horizontally, and then I make that width half of my 5.4 millimeters. So I make that 2.7, and then that last point there, I also horizontally constrain that. And so then when I put that line on a 45-degree angle, let's see, oh, and give the 5.4 millimeter measurement, then it becomes fully constrained, and I'm ready to draw the arcs on the inner wall. Now, the arcs on the inner wall are a lot easier to make. I don't have to use any construction lines. I just make each center point 5.4 millimeters to the right of the outer wall center point. And I horizontally constrain the 2 center points and horizontally constrain the end point. And when I finish those 3 operations, it becomes a fully constrained sketch. So here you can see first I'm horizontally constraining the 2 center points, then I'm making them 5.4 millimeters apart, and then I'm horizontally constraining the 2 endpoints. And once I do that, it becomes a fully constrained sketch. And I'll do that for each arc all the way to the bottom, and to the bottom of the drawing. And on that last arc, I'm not going to come all the way to the bottom of the drawing because I want, where that meets the drum head, I want the wall to be thicker. So to give it a little more stability where it meets the drum head. So I'm going 5.4 millimeters thickness all the way along the wall, except on that part where it meets the drum head. I almost double the thickness there. Now I have 2 more arcs to do here. And the third one, I go ahead and horizontally constrain the center points. I make them 5.4 millimeters apart, and then I'm almost ready for the last arc. Now I have to zoom out a little bit because this one has such a large radius. And one of the things you're going to notice is that when I draw a line along the x-axis, which I'll end up doing next, it'll give me an error message because it automatically constrains the line to the x-axis, and it constrains the endpoints. So that's over-constrained. If you constrain both endpoints to the x-axis and then constrain the line to it, it'll give an error message, and it does that automatically. Now also it tends to nest all of the dimensions in one spot, and so I'm going to kind of move those down so that you can see them a little better. And now if I zoom in, you'll see what I'm talking about when I put this first line on the x-axis. And don't worry when it gives you one of those error messages. All you have to do is delete the extra constraint. So there's the error message, and I delete the extra constraint, and it goes back to green, and then I delete the error message. Now this is going to be resting against the print plate. This is actually the direction I'm going to print it. So when I print it, that's really a small area on the plate. So I'm going to put a 3-line brim on this print, and then take the brim off for the other 2 prints. So you'll notice that part of that line I bring in at an angle. If I made that entire line along the x-axis, the drum head would vibrate against that. And even with that 1.8 millimeters, I'm going to take sandpaper and very, very gently round that, because you don't want the drum head to rattle against a flat spot. So now I'm going to set that line at 45 degrees, and I'm going to set those 2 points at a horizontal distance. Even though they're not in the same, even though they're not horizontally constrained, you can set those 2 at a horizontal distance from each other. And after I do that, the last thing to do is to click on those 2 points and make them the same, and then the sketch is fully constrained and it's ready to be rotated. So now I'm going to click close on this, and if it doesn't automatically go into the task menu, I'll click on task. And you see in the task menu, revolution. So I'm going to revolve this. And when I do, you'll notice that I have to change that back into the correct view. And there it is. Now I'm going to turn this 180 degrees. And that's the orientation that it gets played in. Now if I save this as a FreeCAD drawing, then I can always go back into the sketch and change something if I need to. If I double click on it and highlight the entire body, then I can export it as an STL file, which is what my slicer will need. I'm going to cancel on both of those because that's something I've already done. And there's my drum body. I hope you've enjoyed this video, and I've got several more to show the rest of how you make the drum and decorate it. And thank you for watching.